sound speeds. And if you're a production sound professional and you deal with wireless microphones, then you no doubt face the dilemma. How do you choose what is the proper amount of gain or attenuation that your wireless microphone setup should have? Well, in this video, we're going to discuss just that. So what's the big deal here? What's it really matter? I mean, as long as the signal comes out of the antenna and goes into your receiver, isn't that good enough? No. Not at all, because your receiver is ideally looking for 0 decibels. That's no amplification, no attenuation. And if it's got a tolerance of maybe 2 to 5 decibels, that's probably doable and workable. But if the signal is too hot going into the receiver, you're going to be overmodulating your signal and introducing too much noise. If it's too low, you may have a signal there, but it may not be strong enough for you to get a really good solid signal. You may be one of those trusting professionals asking one of your friends in the know what is the best antenna to use with your receiver. And then you simply connect up an antenna cable between the two of them. But what you don't understand is all of it matters. Not just the cable itself and what you connect up to it on either ends, but the length of cable, how thick it is, what's the loss, what's it rated for. All of that does matter. In this video, I'm going to show you how for less than $100, measure the amount of decibel gain and loss and then compensate with amplification or attenuation before it goes into your receiver. Now, it should be noted that this is a $100 solution and is by no means the end-all be-all solution. This is a low-res, basic troubleshooting to use in a pinch kind of solution, but it's going to give you some results. Kind of the equivalent of when you watch a movie, it's VHS versus 4K, or if you take your car into a shop, you can take it and get a professional to maintain it and look it up and give it a tune-up, or you can watch a couple of YouTube videos and hope that you're going to get it right. Production sound professionals, I ask you, how often do you rely on something wireless? Wireless lavs, maybe? Wireless boom? Maybe even transmitting your video over to your sound cart? Well, if your answer to any of those questions is that you do use them, then you need to take your RF seriously because your audio relies on it, right? So it's very important for you to keep it constantly tuned up, which is why my friends Scott and Cujo over at RF System Consultants can certainly help you with that, and I put links down to their company down in the description. The tool I'm going to be showing you in this video is called a NanoVNA. That's a vector network analyzer. A lot of ham radio operators and people that do radio and that kind of thing as a hobby, they're definitely familiar with this because it's a very important tool to have if you do this as a hobby and you don't have access to multi-$1,000 tools and you don't want to, sell your car to get one of those. There are many different VNAs on the market. Some have different size screens, some offer different features, different frequency ranges, that kind of thing, even resolutions. And so it's very important for you to buy one that has good ratings and isn't going to just crash on you constantly and give you bad results. So definitely you want to make sure you don't get yourself a bad brand. And I put links down in the description if you want to buy the one that I use. RF is insanely critical for what we do, and it's also ever-changing, not just studios versus locations, but it's also one of those things that if you use a different cable, or that cable happened to get run over by a condor when no one was looking, it could very well affect its performance. So it's important for you to understand how to measure. And without further delay, let's get into this demonstration. This is a NanoVNA. It's the version that has a 4-inch screen. If you look on the left-hand side, it says channel 1, channel 2 for those SMAs. It might also, on some models, say channel 0, channel 1. And there are different models of the NanoVNA for you to take note of. Now, this particular version is the one I use, and I put links down in the description if you'd like to check it out. Now, if you look at this version from the front, it just has a big touch screen. But if you look at it from the top, it has a place for a micro SD card. It has a place for it's a power switch right there, and then it has a little left and right wheel that you would use to select certain things, and we'll get into that in a little bit. If you look at the underside of it, it has a place for you to plug into a USB-C, and there's really nothing on the other side. But there you go. There's the NanoVNA. Now, VNA rather. If you look at the back, it does tell you that this is a NanoVNA H4. And again, I put links down in the description if you'd like to check it out. That is the QR code that will take you to nanovna.com. Now, the thing to note about this particular model is that it is good for basically up to 1.5 gigahertz. So if you're looking for 2.4 gigahertz or 1.9 or anything higher like Teradek, you're not going to really find anything in that range. But the optimal frequency range right here is 50 hertz to 300 megahertz, and that's at a 70 dB dynamic range. And from 300 megahertz to 900 megahertz, it's a 60 dB dynamic range, and above 900 to 1.5 gigs, that is at, I think, 30 or 40 dB dynamic range. I can't really remember. But we'll go ahead and set this up for ourselves here by turning power on. We're going to see that it automatically defaults to what looks kind of like a confusing screen when you first turn it on. Well, it may be intimidating, but you don't need to really pay a whole lot of attention to this. Let's go ahead and go. Let me first go. Okay, well, brightness is all the way down. That's fine. But I'm going to go over here to display. And the first thing I'm going to do is I'm going to turn off all these other traces. We're just going to be very simple and start with one trace. Okay, that's one of these little lines going across. Going to go back. And since we're going to be testing the throughput of a cable, I'm going to change this channel from S11, which means just using channel 1 to go out maybe to an antenna and back and test things that way. Instead, we're going to be using port 1 and port 2. So I'm going to change this not to reflection, but we're going to change this to through. So channel 2, 1 for through. Now, going through some of the settings here, if we were to start at the very beginning, let's just start here at the bottom actually. Config, if you go there, there's really not a whole lot to look at unless you connect it up to a computer, in which case you'd want to make sure that it's set up for USB, which mine is by default. Expert settings, you should avoid this area. You don't really need to go in there. And if you need to calibrate something, touch test or calibration test, you can. Now we're going to go ahead and bounce out of here, and we're going to go next to, let's go to calibrate. No, let's skip calibrate for right now. We're going to go up to stimulus. That's basically the frequency range that we're going to be operating in. Now you can choose a center frequency and then a span if you'd like to. Not everybody might know the frequency span for the UHF frequencies that we operate in. It's 138 megahertz span centered around 539 megahertz, but we're not going to get into that. Instead, people will know the frequency range is 470 megahertz all the way up to a stop of 608. And if you look at this, this is gigahertz, megahertz, kilohertz, and that's it. So we're going to click megahertz right there. So now our frequency range starts at 470 megahertz and it stops at 608 megahertz. So let's go ahead and go back out of this. Now, the sweet points is kind of interesting. This is basically the resolution of the width. So for this size screen, really you don't need to go higher than that. If you go higher to like 401, for example, it goes very slow. 301 also goes slow. 201 isn't that bad on this particular unit. It's pretty good. And 51 is pretty low res. We're going to actually put it at a pretty optimal place for this size screen. That's 101 points. So I'm going to go back. The rest of this I really don't need to mess with. So I'm going to go back again. We're going to now go to marker. Now, marker is basically, it gives you multiple different places of information if you'd like to engage them, and you can set what different markers do. We're just going to leave on our basic marker. It's going to basically tell us information we'll get to on the next screen here in a second. And for that, the rest of this looks fine. Measure, make sure that's off, which it is. If we were to engage one of these things, it's going to basically say, it's going to have the information on the side. If you do something that it doesn't acknowledge and doesn't understand, then it's going to say, it's going to tell you that on the left-hand side. We're going to go to off for right now, though. But the thing to note about this screen is it says measure 50 ohms. And that is going to be critical because the cables that we use are going to be 50 ohms. So we're going to make sure it says 50 ohms right there, bounce back. Now, we're done with marker. We're going to go now to display. Now, a few different things to note here. Channel is set to S11 right now. That's for reflections, just using channel 1. Channel 21, S21 is going to be going from port 2 to 1, vice versa, for a through measurement. Bandwidth, you don't need to mess with that a whole lot. Now, data smoothing, you can smooth it if you really like to, which makes it a lot less accurate. We're going to turn smoothing off. I don't ever use smoothing. You want it to have as much accuracy as you possibly can, considering this is a pretty low-res unit, let the truth be known. And as for format, this is all the different things it can measure. Like, for example, for example, right now it's set to log mag, which is what we're going to be using to test the throughput in decibels of our cable. You can check your phase, delay, the Smith chart, the SMR, the resistance, reactance, and there's even more on the next screen. But we're not going to really go much past that in this video. It's just going to be log mag is where you want it to be. Now, on the right-hand side, rather, this particular model, if you look, actually is pretty cool because when you look under scale, it has two different things to note. Reference position is the first one, and I usually leave it at 7. The reason why is because you see that there's some information across the top here, and if you were to count starting with 0 at the bottom, 1, 2, 3, 4, 5, 6, 7, 8, 8 is the very, very top, but 7 is right below that. So that's where I have everything centered. If I wanted it to be right in the middle, because I'm going to be measuring above and below the line, reference position, 4 would be 0, 1, 2, 3, 4, which is right there where 0 is. So we're going to be measuring from that center line. But we're not going to do that for our purposes. 7, because when you're talking about loss on a cable, we're not actually going to see anything above that point. So we're not going to mess with anything above that point. Now, scale division. Now, here's what this is. See on the right-hand side, if you're measuring a cable and you're running into loss, you don't need to measure like 0 dB, 10 dB, 20 dB, 30 dB. If you're experiencing 60 or 70 dB of loss on a cable run, that's pretty bad unless it's a super long cable. And even then, it's pretty bad still. So why don't we just go to change that? We'll change it to 1 to start out with. That means from 0, this is 1 dB of loss, 2 dB of loss, 3, 4, 5, 6, and so forth. Once we get our configuration the way we want to, let's go over here to back and configuration, and we're going to save this configuration, so now it's going to be the same way anytime we turn on the unit. The NanoVNA comes with everything you need in order to calibrate it properly. You have an open, which if you look on the inside, it looks kind of like the letter O. Then you have what's known as a short, which is the same material as the connector itself. It's just made entirely out of, what is it, brass, bronze, probably brass, I don't know. And then you have this one that looks kind of a combination of a couple of different metals, and it looks like an antenna on the inside. It looks like a regular looking connector. It's not just metal all the way through. You also have what is a barrel, a turnaround. So I'm going to start by connecting this up to the end of these little leads that also come with the NanoVNA. The reason why I use those as opposed to calibrating it directly from the post right there is because you want to calibrate out and zero everything from a position of, not considering the cables that you're connected to. So if you calibrate everything with these all connected, then it's only going to be measuring that which is connected up on the other side. So for starters, what we're going to do is we're going to go over here and go to calibrate, 4th down, and then go right over here to calibrate. Now, actually, first thing I'm going to do is hit reset before I go into the calibrate. That's going to make sure that everything is set back to normal, back to a state of ready to be calibrated. So if we look here, this is the open. I'm going to connect this up to the end of the line that is on channel 1, okay? And then I'm going to go over here and hit open. Once it takes that calibration, there's going to be a little checkbox on it. I'm going to undo this one, and the next thing it's going to do, and we're going to put on there, is the short. Now, the difference between open would be like if you don't connect up anything. Like right now, there's no antenna connect up. That's basically open. And a short would be if the little pin on the inside and the outer casing of the connector were to make contact. And so that would be a short, shorting out the grounding to the pin on the middle, the antenna itself, the positive line. Okay, so we have got our calibration for short. We're going to now go over here to the load. Now the load goes on there too, and now this is just like a standard antenna connector, but without the antenna. So it's actually optimum conditions for measuring a load, except that there is no antenna actually connected. So there we go. All right, we're going to disconnect this. Now we have 2 more calibrations we're going to do, and technically those are the only 2 we really need in order to do a through calculation for checking our cable, but you always want to get into the habit of doing them all. The next one is an isolation, and the isolation is just if the 2 of these cables are just in the air, so they're both open. Isolation. And the last one is the through. Let's screw these 2 connectors together. And right now you can see that looks a little bit off. We're going to go through, and then we're going to hit done. And then I'm going to save this to position 0. Now that means that every time that I start up this machine, it's going to automatically default to save 0, because save 0 is like their default stat. So that should be what comes up. Now, if you notice here, there's a line right there at the position 7 mark right there, 0, 1, -1, -2, -3. If you notice, this isn't very much. It's barely moving at all. So the first thing I'm going to do in order to check that is I'm going to zoom way in on it. And so in order to do that, we're going to go to, oops, not marker. We're going to go to display, and I'm going to set my scale. And instead of being 1 dB increments, I'm going to set it to 0.1 dB increments. So now this is negative 100 milledecibels, I guess you could say. And it shows that there's a little bit more actual to that line. So if I can actually go to negative 0.1 and really zoom in, and that shows that there's actually some activity happening there. But when you zoom that far in, this is like 1/100th of a decibel. That's 2/100ths of a decibel, 3/100ths of a decibel. You can see that it's bouncing around, and this is perfectly acceptable. That's just to show you the zoom in powers. Now I'm going to go back to 1 for right now. And if you look up here, it does say S22, or I'm sorry, S21, because we're taking measurements from here to here, post 1 to post 2. And it does say log, mag, and then it says 1 decibel. That's a 1 decibel increments. But because, if you remember, we can show the grid values right there, we can actually turn that on because we have the resolution on the side of the screen. So if it's a smaller NanoVNA, you might not be able to turn those on. So that's one of the really cool features about this. Now we're actually ready to take our measurements now. So we're going to go back to our main screen. Now for this, you're going to need to have a couple of different types of adapters. And depending on the kind of connector of cable that you're going to be measuring, you will want to make sure you have a selection of different types of adapters. And that's what I bought right here. I have various different adapters that we can use for basically every kind of possibility. And notice that some of these have the male end on it, some of them have the female end on it, and it has different types of connectors depending on what kind of antennas you're going to be connecting up to and which post and which end. Reverse polarity is in there. You have regular SMA. You have basically everything you need. Now, for our purposes here, I'm going to be grabbing this one right here, and we're going to be using that on the end of this cable. Now, technically, this cable is a 50 ohm cable, and it is for a 2.4 gigahertz antenna that I bought for my DAD BPTRX review. So I'm going to go ahead and plug this on right here, and I'm going to unplug this little cap. So this is now ready for me to connect up to the NanoVNA. I'm going to connect up this end, and most connectors that you see and cables are going to have approximately 1 decibel of loss or more. So if I connect this up, you can see it's starting to do some activity over there, and it's going to show right there what the actual rating, or rather the measurements are. And this is frequency response. Whoops, I've got to reach over there and grab this. This is a frequency response of the signal. It's basically the signal starting over here with 470 all the way up to 608. And this shows not the frequency response, rather the decibels, how much decibels it is in loss. So considering that this is 0, we're never going to really be hotter than that. You can use the little wheel up at the top, and you can dial in and see, like at this particular point, which is at 486.560 megahertz, we are experiencing negative 1.13 decibels of loss. And you can use it and scroll down this way, or you can just do a faster method, and you can use the little stylus right here and say, if I'm using only wireless, let's say around 565, I can just take it over here to around 565 and then say, well, we're looking at about 1 decibel, 1.17 decibels of loss, plus or minus a little bit right there. And it will tell you exactly what that is. If you want to zoom in even farther, remember that's your scale. So you can zoom in on the scale, and I'm going to say, let's look at this. Let's go to 0.25. So now we can see that there's the 0 mark. This would be the 1 mark, and it fluctuates just a little bit. But then considering that this is 138 decibels or 138 megahertz of range basically from here to here, you can see that it's not fluctuating that much. I mean, the biggest peak right here is only a loss of 0.70 decibels, and the biggest amount of loss would be right over here, which would be 0.14. It's bouncing up and down. So it's like it's maybe around an average of 1.35 decibels, somewhere around there. But if you were trying to calculate how much loss to add to your, how much gain to add rather to your antenna to compensate for this amount of loss, really you only need 1 decibel of 1 dB of boost. So you don't need to compensate for any more of that by boosting up your antennas overly hot. It should be everything you need to know right there. Although I just measured one cable in this video, you could very easily also take the cable out of your antenna, take the cable out of your receiver, plug those into the Nano VNA, and trace your entire line, keeping in mind that your decibel level will change according to the length of your cable, what brand of cable, and what have you. Now, a couple of other notes here before we finish this video. It's very important that if you're going to use adapters in order to measure different types of connectors, let's say, that you have enough adapters. So I bought not just one, but I bought 2 of the kits that you'll see down in the description below. I find it very important to carry multiples of them because if you just get one of them, it's going to have a reverse polarity on BNC. It's going to have a BNC male, BNC female, male and female on the SMA end, and you're only going to have one of them. So if you try to connect up both ends of your cable to the Nano VNA, you need to have an entire kit of 2 adapters per. So buy 2 of them, don't just buy one. The last note here is that your cable may measure within a certain frequency range and be all over the place, but that doesn't necessarily mean it's something to throw away, even if you may look at it and say, well, geez, 470 to 608 is garbage, it's all over the place. You might want to also measure it for the Comtech range around 172 megahertz, because it could be completely wonderful in that spectrum. And you also, if you use anything up and around, 941 to 960, then you might also measure it up in that realm as well, because it could be fine up there, even though it's completely toast for UHF frequencies. Now, if you have any other questions, feel free to put them in the comments below. And if you are looking for a professional solution to scanning your entire wireless system, determining if there's any loss, determining if there's any really any RF in your own system that you're generating from your LED fixtures or your lights, or maybe even your power is causing RF issues, then consider again contacting my friends over at RF System Consultants and make them your friends. Thanks for tuning in to this episode of SoundSpeech. Be sure to tune in the future for more interesting things that may save your signal, your audio, and of course, sound advice. Have a question you'd like answered or want to add something? Be sure to write it in the comment section down below. You can also make a suggestion for future topics of discussion. Again, comment section down below, or you can email me at soundspeeds@yahoo.com. Be sure to subscribe and turn on notifications so you won't miss out on future sound advice.